Let me directly get into, or there's a planet, I'll write it. Now, what is the field strength at a distance h, at a height h above the surface? Since what happens is so massive or so large that it will appear like a flat, but in fact, what is the planet? Planet is a spherical, that one. And what is the field strength at this particular point? So what is the formula? Gm by r square. And what is r? H plus r. This radius is r, no? So the total at this particular point, what is the field strength at point P? It should be equal to Gm by r. R I'll measure from the center. Now, what is the unit for this gravitational field strength? Force per unit mass, no? Force experienced by test charge kept at that point. Force experienced per unit test mass kept at that point. What is the unit for this? I think we gave, no? It was a Newton per kg or meter per second square. So what is the gravitational field strength? Nothing but shall I say it's acceleration. And when you call this as like a planet, the gravitational field strength, I'll call that as acceleration due to gravity. So what is the basic unit for this? Meter per second square. If I find out gravitational field strength for a ring, for a disk, I'll call gravitational field strength only. For a planet, when I calculate the gravitational field strength, I'll give specific name. I'll call it as the acceleration due to gravity. Why acceleration? Because if you release any test mass here, let's come. So here is the test mass is there. This test mass, what happens, will experience a force. So what is the acceleration of test mass? F by m naught. And what is F is equal to? This should be equal to E only. And this should be equal to how much? G, or I'll bring it in systematic way. And what is the force of interaction? This should be equal to G m m naught by r square m naught. So Gm by r square. And this is nothing but E, no? The same thing what I brought. So therefore, for a planet, what you calculate gravitational field strength, that is nothing but called as acceleration due to gravity. I'll call it as now acceleration due to gravity. Now, why acceleration? Because why this acceleration is there? Due to gravitational force only. So what all that test mass, it will have acceleration that is purely due to gravitational force. I'll call it as acceleration due to gravity. Finish show. Got the idea? So nothing too big. Anything you need not to do anything very big. Means now what is acceleration due to gravity? On the surface of the earth. So on the surface of the earth, will give a specific value for it. And this is the center. This is the surface. So what is the acceleration due to gravity at this particular point? Point 1. This should be equal to Gm r square, no? Because small r will become capital R. Small r will become, because when you bring this test particle, keep it on surface. So what is small r? Small r will become equal to capital R. Then this particular specific value, I'll call it as G. Able to understand? This will, on the surface, we know what is the gravitational field, Gm r square. That particular gravitational field on the surface will give one specific value for it. Because why we should do? Because where do we live? On the surface or at a height of 10,000 kilometer or at a depth of 5,000 kilometer? We are living on the surface, no? So therefore, that particular value of gravitational field on the surface is something very important. I'll give one symbol G. And this is what we say approximately equal to how much? 10 meter per second square. Is it really a constant? As you move up according to this formula, look at this formula, according to this formula. So what is acceleration due to gravity? Is it a constant? No, it is variable. On the surface of Earth, it is equal to G. So as you move up, what should happen to acceleration due to gravity? H increases. Then acceleration due to gravity should decrease. So now we are going to study that variation of acceleration due to gravity. This is something very important. The idea of gravitational free strength only is being called as acceleration due to gravity for a planet. For a ring, I should not call. What is the acceleration due to gravity? for a ring. I think that we don't have any planet which is in the form of a disk or in the form of a ring. So exclusively acceleration due to gravity is used only, the word is used only for what? For spherical objects, that is for planets. Getting that one? Okay, let's discuss some cases here. First, variation of g with height. Let me put in fresh page. Variation of g with height. So let me take this one. So we know on the surface how much it is equal to g. At height, how much it will be. So g dash is equal to, on the surface of the earth, how much it is? Gm r square. What is the mass of the planet on the surface, that one? Then at a height h, how much it is? G dash equal to gm r plus h whole square. So let me take r outside from it. Gm by r square, what you can write? The gravitational field strength on the surface of the earth, we give one specific name. What it is? Small g. So gm by r square, what we can write it now, is equal to g by 1 plus hr whole square. Now what is h? Usually h will be less than r. So from binomial expansion, or this will become 2h by r. Or we'll send it to the numerator. Then from binomial expansion, this will become higher order terms, you can neglect it. So this is the expression for acceleration due to gravity at height h. Now don't make h more than r. So this is applicable for h less than r, no? Means sir, at h equal to r by 2, g dash will be 0. No, don't go to that height.